quadratic function, which if you graph it is a parabola, and has to find the x-intercepts, which is the same thing as finding the roots of 9x squared plus 72x plus 71 equals 0. And you're supposed to use radicals. So here's the answers. One of the roots is negative 12 plus the square root of 73 all over 3. That's this x-intercept. And the other one is negative 12 minus the square root of 73 over 3, which is this x-intercept. Question is, how do you get these answers trying to solve this equation? Okay, well, there's two basic ways to do it. You can use the quadratic formula where you identify, since it's already equal to 0, a is 9, the coefficient of the squared term. B is 72, the coefficient of the linear term. C is 71, the constant term. X equals the opposite of B, negative 72, plus or minus the square root of 72 squared, B squared, minus 4 times A times C, all over 2A. That's what you get after you substitute into the quadratic formula. Here's the work that I did manually to simplify the discriminant, or the value under the radical. 72 squared is 5184. 36 times 71 is this 2556. So b squared minus this is 2628. I find the prime factorization of 2678 and saw that it was 2 squared times 3 squared times 73. So the square root of 2 squared is 2. The square root of 3 squared is 3. That's why I wrote 6 square root of 73 as the simplest radical form for the square root of the discriminant. And at that point, you can divide every term, numerator, denominator, by 6, because 6 goes into 72 12 times, 6 goes into 18 3 times. So there's your roots, negative 12 plus the square root of 73 all over 3, and minus. Now another technique to solve, and I think it's actually easier, is to complete the square. The suggestion to complete the square over the quadratic formula happens basically when the coefficient of the x squared divides into the coefficient of the linear term evenly. Then it's pretty easy to complete the square. So take the constant term to the other side, divide every term by 9, complete the square, take half of b and square it, 16. Add 16 to both sides. That point, the whole point here was that this is now a perfect square trinomial, which can be written as x plus 4, the quantity squared. If you get a common denominator here, this actually converts to 73/9. So it's starting to look like the other answer. If you take the square root of both sides, square root of the numerator plus or minus the square root of 73, square root of the denominator 3, subtract 4 from both sides, get a common denominator if you want to combine it into one fraction. There's your answers. Okay. Looks to me like completing the square is actually a little less work than the quadratic formula. But there you go. Hope that helped. If you have any questions, post a comment.